you'll remember that when we calculate for the surface area of something, we need to do its development. So the first thing we're going to do is we're going to note that the top is made of a circle. The bottom is also made of a circle. And then the middle part is made up of a rectangle right down the middle, right? So if we want to calculate the area or the surface area of this shape, we are then going to have to calculate for the area of the circles plus the area of the rectangle, right? Now, we know that the area of a rectangle is length times breadth. We already have the breadth because we know that's going to be 5.3 meters, 5.3 meters. But who remembers, how do we find the length? How do we find the length of our rectangle? Who remembers? It's the something, it comes from the something of the circle. Correct, Akwando. Oh, I see, Samuel. We're just happy to have you back. Good. It's the circumference of our circle. Good. So the length we're looking for is the circumference of the circle, right? We know that circumference is going to be 2 times pi times the radius, right? And they've given us the radius of our circle, so we can calculate the area of our circles. We know that the area of a circle is pi times radius squared, right? But we've got 2 circles. So we're going to go that the surface area, the total surface area is equal to the area of my circle times 2 plus the area of the rectangle. Okay. But in order to find the length of the rectangle, we need to calculate for the circumference of the circle. All right, I'm going to give you guys a second. If anybody's got an answer for us, please pop your answer in the chat. Okay. I'm going to steal your answers because I'm too lazy to take out my calculator. Where's my bag even? I don't know. Akwando, can you set to per 3? Yeah. Akwando, I'm going to need you to ask that question again in a way that I can understand. Oh, can you say, yes, you can. Yes, Asbonge, that's why I wrote 2 pi r. Do you see that? 2 pi. Yes, absolutely, Akwando, you can absolutely do that. So when you put in your calculator, you can just go 2 times pi times the radius squared, which shows that that 2 means the 2 circles, 100%. Plus, okay, let's calculate the circumference quickly so we know exactly what it is. The circumference is going to be 2 times pi times 4.3, and that's going to be our length. Okay, so let's calculate for the surface area very quickly. We know that the total surface area is going to be 2 times pi times the radius, which is 4.3 all squared. That's going to cover our circles, plus the rectangle with length of 2 pi times 4.3 multiplied by the breadth, which is 5.3. Can somebody put this into a calculator for me and give me an answer, please? Who's got an answer for me? Okay, I want to see if everybody's answer looks exactly like mine. Correct to 1 decimal place. Oh, Apiwe, are we sure about that number? Because I got a completely different number. My answer looks like Amber's. My answer looks like Amber's. 1 decimal place, Amber. The question says 1 decimal place, guys. Let's make sure we're doing the correct things. Okay, all your answers are correct. Well done, Asbonge. Yes, Waylon, remember 1 decimal place though. So the answer we're getting is 259.4 meters squared. Okay, and that's the answer we're getting. All right. Okay. All right. I know that was quite the long introduction, but that is just something that we did in the last lesson. So welcome to Watobe, everybody. I hope we're all doing great. If you are joining us for the very first time today, can I ask you to pop a hello, I'm new in the chat for us, so we can give you a nice big fat Watobe welcome. Akwando, make sure that you're putting all your brackets around everything. Put brackets around everything.
Did you put a dot after the pi? Because I feel like because instead of multiplication, ma'am used a dot. I feel like
oh yes, yeah. Sorry guys, sorry. These are all commas because of the decimals, but the brackets, yeah, sorry about that. Sorry about that. Hello, Cassidy. So today we're going to be tackling volume, guys. And before we continue, let me just make this a little bit smaller. I'm going to ask you guys to take a quick screenshot of these formulae. If your brain is the type of the thing that works with formulae, we need to understand what the formulae are in order to use them. So everybody's got 5 seconds to take a screenshot, and then we're going to get started. So 5. 4, skip a few, 1. Okay, let's get going. All right, we're ready. All right, so I just want to remind you of a couple of things. The most important formulae that we're going to be using here that I cannot give you are your spheres. The things that have sides that slant like this, okay, those formulas I'm going to give to you. But if we have any sort of prism, that means shape that have the same type of perpendicular height. That one has the same height as it does on this side. This one has the same height as it does on this side. This shape has the same height as it does on this side. For these kinds of shapes, we are going to use the following formula so that we don't really have to learn it because it's the same thing. We're going to use the fact that our volume is equal to the area of the base multiplied by the height. So if I have, let's say, for instance, I have a cylinder, right? What is my base shape? Guys, what shape do I have at the bottom over there? Tell me in the chat. What is the base shape? Correct, Funzo. And we know, yes, Waylon, correct. We know the area of a circle. We've dealt with the area of a circle before. The area of the circle is going to be pi times the radius squared. Okay. Once we've got the area of that circle, we're just going to take that and multiply it with the perpendicular height. So that height over there, perpendicular height. All right. So that's how we're going to work through these. If we've got prisms, only if we have prisms. If we get things like pyramids and the such, I will show you guys what we need to do in those instances. So, I'm going to ask you guys, I'm going to give you the formulas when we start looking at those. All right, without further ado, let's start with something a little simple. Right, calculate the volume area, the volume. We're not doing surface area anymore. So we're just going to be calculating for the volume of the 2 following prisms. Okay, once you are done, pop your favorite emoji in the chat. I will show you guys my favorite emoji. I saw one of the boys use it today when we were doing revision, and I thought it was the coolest thing. I even forgot about it. I remember it now. Where is it? I'm hoping it's here because it was just the funniest thing I'd seen in a while. Where is it? Oh no, I don't think they have it here. I can't see it. I think it might just be on Microsoft Teams, but I'm not seeing it here. Okay, fine.
If you explain, I'll try and find it while you continue with the lesson.
Okay, so there's a dude, it's like a ninja guy, but it's like inverted. You know what I mean? Like it's a ninja, but it's almost like he's wearing like white ninja clothes with black glasses. I think they have that.
Okay.
I don't know if they have the ninja guy. Okay. Amber's like, Ma'am is doing my homework. No, Amber, do your own homework. Amber, you must do your own homework. I can't be out here doing your homework for you. I don't think I'm going to find a teacher now, but it was so cool. I think maybe because some of my boys have, you know how if you have this version with all the screens as white, you can turn the screen like dark mode.
Yeah.
And that also kind of changed the emojis as well.
Oh,
Because
yeah.
it's like what Amber has there, but it's in like the opposite colors, right? So the person's wearing like it's a ninja wearing white with two swords like this, and then just a black mask for the face. So yeah, I don't know. It was the coolest emoji I'd seen in a while, but it's fine. It's fine. I'll find it one day. One day is one day. I'll find it. Okay. I'm pretty sure we're all ready because these questions aren't that difficult, right? Let's look at the volume of the very first one. The volume of the first shape is going to be the area of our base, which is a rectangle. So we're going to have length times breadth multiplied by the perpendicular height, right? True, Akwando, we love your food, baby. We love your food, baby. So we're going to say 8 centimeters times 2 centimeters times 6 centimeters, right? And our volume should be, I don't know about 76. Is it not 96, Tyrika? Are we sure about that? Yeah, I thought it was 96. Yes, correct. 96 centimeters cubed. Yeah, it's 96. All right, so that was easy enough. The volume of this one over here, again, because our base shape is a rectangle, we're going to have length times breadth multiplied by the perpendicular height, which is going to give us 5 meters times 4 meters times 7 meters, which is 140 meters cubed. Now, I'm not going to rate these questions. These questions are too easy. We are looking at things just in J. Too easy. Let's keep moving. No worries, Ontatile, welcome. All right, here's your next challenge. We are going to be calculating for the area of these cylinders. Now, we know that our base shape is the circle. So we know that the volume of a cylinder, the volume of the cylinder is going to equal the area of my base shape multiplied by my perpendicular height. Okay, so take it away, guys. Once you're done, again, Akwando, I want to see your food baby in the chat. I want to see your food baby in the chat. No worries. Hello, close bracket. Hi, Pascal. Welcome. No worries. Oh, so good to see everybody back. It's very nice. I like it. Ah, no, man. Okay. Yeah, I think maybe, you know what, teacher Nels, I think it might be like other people's settings. You know what I mean?
Yeah.
Like sometimes when you're on a different device, it doesn't give you all the emojis all in one, you know? In this case, Kellen, I'm just, okay, let's get rid of 3 significant figures. This is actually a maths lit thing. We're not going to be doing significant figures. Give me 1 decimal place, please. Give me 1 decimal, Kellen. Give us one decimal, please. Okay, Apiwe, favorite emoji, 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 emoji. All right, guys, one more minute. No worries. One more minute, guys. All right, peeps, that's time. Okay, let's look at the answers for each of these. Now, I know volume is equal to area of base times height. So we're going to take a nice one, Irene. I like it. Okay, volume is equal to pi r squared multiplied by the height. Now we have the radius. They've given us the radius. So we're going to put the 8, pi times 8 cubed, 8 squared times 8. Right. Okay, and now you can pop your answers in the chat for me. Right, in B over here, thank you, Jenna. Excellent. I'm also going to have pi times radius squared times height, which is going to be pi times 4 squared multiplied by 10. Okay, beautiful, Jen. 1608.5 centimeters cubed. And on this side, how much do we get? I know it's supposed to be like what? 160 pi, I don't know what 160 pi is going to be. 160 times 3, 502.6. Thank you, guys. 502.6 centimeters cubed. All right, I'm going to ask for a thumbs up if you guys are okay with this. I didn't think it was going to be too difficult for anybody to get these answers. I think we're all on the right track. Yes? Beautiful. All right, excellent. Okay, let's jump into these next questions. Now, I want us to think very carefully about where we're going with this particular question. Okay, now, if we look at this question 3a, I know that the volume of this shape is going to be the area of my base multiplied by my height. But let's first start by talking about the base. In this shape here at A, what is our base? What is our base shape? Tell me, what is the base shape? Okay. Now, I knew we were going to say rectangle. Wayland's like, rectangle? Question mark? Okay. Okay, so everybody's saying rectangle. Now, I'm going to say that we're all wrong, except Kellen, because Kellen is the boss, and Kellen has it 100% correct. Beautiful. Kellen, if you were in my class, I would throw you, I hoist sweets at my kids all the time in my class. I would give you a sweet because you are just high five. Well done. Okay, let's just talk about this quickly, right? When we look at this cylinder that we have over here, we all agree that my base shape is my circle, right? But now you're going to notice that when I have my base shape of a circle, I've got a circle at the bottom. I've also got a circle at the top, which means that my height for both of these things, or for my shape, is the same everywhere. My height everywhere is going to be 8 centimeters, 8 centimeters, 8 centimeters. Give me a thumbs up if what I'm saying makes sense. Do you guys agree? All the way around my shape, the height of my shape is going to be 8 centimeters. Yes? You guys with me? Excellent. Good. All right. We're all on the same page. Now, let's look at this question over here. Let's look at this question over here. Now, if we use the rectangle as my base, is the height of this rectangle 7 centimeters everywhere? Is the height of the rectangle 7 centimeters everywhere? No, it's not. It's only on this side. What about the height over here? What about the height over there? The height over there, that's not 7 centimeters. So we couldn't possibly look at the rectangle as our base shape. Now, let's go with what Callan is saying. Callan says that the triangle is our base. Now, if I use my triangle as my base, is the height of this triangle as the base going to be the same everywhere? Yes, it is, because that part there is going to be 12 centimeters. What is the length of that part of my triangle going to be? The height of that triangle. What is the height going to be there? What's the height going to be, guys? 12 centimeters, exactly. 12 centimeters. And then the height of that part over there of my triangle, also 12 centimeters. So do you see why? Give me a thumbs up if it makes sense why Callan says that the triangle is our base. Okay, beautiful, 100% accurate. Okay, so we always need to use the thing that's going to give us the same height on every side. That is our base, the shape that gives us the same height on every side. The easiest way to spot this shape is if there's one on one side, if there's that shape on one side, and that shape is also on the other side of my prism. Okay, in this case, the rectangle, no. There's only a rectangle at the bottom. Is there a rectangle up here? No, there isn't. So we can't use that as the base. We can only use the base as the two sides that are equal. So we now know that our base is going to be our triangle. So we're going to use the area of a triangle. We know that the area of a triangle is half of the base multiplied by the height. And then we're going to multiply that by the height of the prism itself, big H. All right. So pop your answers in the chat once you've got an answer for me. Okay. Well done, Callan. That was beautifully spotted. Beautifully spotted. Okay, pop your answer. You can, once you're done, guys, you can just pop your answers in the chat for me. Beautiful, Jenna. Lwandile, you're going to have to zoom in or out. Okay. Okay, excellent, good. So we're going to get, the volume is going to give us 1/2 multiplied by the base, which is 2.5, multiplied by the height, which is 7, multiplied by the perpendicular height of our whole shape of our prism, which is 12. And the answer we should get out of here is 105 centimeters cubed. So Funzo, I'm watching you, Cassidy. Where is my centimeters cubed? Remember, we are calculating volume. When we just say 105 or 105 centimeters, what exactly did we calculate for? We must remember that. Okay, we must remember that. And if we can calculate for A, right? Thank you. Thank you, Funzo. Thank you. All right. We can then calculate for B. Now, if we look at B now, look at B with the knowledge of what we have. What is our base shape going to be for question B? Correct, Pascal. Beautiful. Volume is going to equal to the area of the base multiplied by the height. Correct. It's going to be the triangle because the height of all the sides from my triangle will be the same on both sides. Okay. So go ahead, guys. They've given you the area. Yes, correct. Akwando, it is slanted, and we're going to talk about that in just a minute because I just realized teacher Nels, they don't teach it. Well, I don't mean that they don't teach it. It's just they wait for, I think they wait for analytical geometry to teach it, and I think that's a bit too late. Yeah, because I teach it. Yeah. I teach this to my grade 8s, so I'm a little flabbergasted as to why. All right, when you guys are done, pop your answer in the chat. Okay, yes, Pascal, correct. Okay, so we're going to have the area of my base, which is also a triangle. So we're going to have half the base, which is 3, times the perpendicular height, which is 4, multiplied by the height of the prism, which is 6. And together that must give us 36 centimeters cubed. Well done, Landile. Excellent. Okay, good job, Funzo and Pascal and Jenna and Callan. Well done. All right. I have no doubts that the rest of you guys also got it right. Well done, Cassidy. Okay. Okay. Yeah. So we're all good. All right. Let's take a second to talk about triangles in general. Okay, because I just realized that we had this exact same problem in the other class as well. All right. So if I give you guys a triangle, let me give you guys a triangle. Right. And I tell you guys that the base of my shape is 10 centimeters. 10 centimeters. And then I tell you that the slant height of my shape is 13 centimeters. Right. And then I say to you guys, calculate the area. No, Akwando, not at all. Not at all. Calculate the area. Now, we all know that the area of a triangle is half base times height. But this height over here, this H stands for perpendicular height. Perpendicular height, right? So it's definitely not that 13 that I've given you over there. That's not the height that we're looking for. The perpendicular height we're looking for is the distance from the apex of my triangle this way. Okay, I'm going to make this side 13 centimeters as well, right? The perpendicular height like that. Okay, that's what we're looking for. This is the H that we want. Now, I'm going to split the 10 centimeters down here. Okay, I'm going to split it because this is an isosceles triangle. I'm going to split this part into 5 and 5. Correct, Akwando. I didn't even finish. Yes, correct. 5 centimeters and 5 centimeters. Now that I know that this is a perpendicular height, that means that there's a 90-degree angle over there. So in order for me to figure out the length over there, I'm going to use Pythagoras. Apiwe, what is Pythagoras? What is Pythagoras? We need to talk about this English. We need to talk about this form of English that I've never heard before in my life. Okay, so we're going to use Pythag to figure out the perpendicular height. Right, I know that my H squared is equal to, true though, is not make sure, is equal to 13 squared minus 5 squared. And now I need to remember, guys, because Pythagoras is part of our geometry, we need to put in brackets over here the reason that we're using this. Remember statement and reason from Pythag? We must write Pythagoras over there. Statement and reason from geometry, we must write Pythagoras over there. So now our H squared, correct, Randile, you're like, yes, past everyone, is going to be 169 minus 25. Sorry, Pascal. So our H squared is 144. 169 minus 25 is 144. But now I don't want H squared, I want H. So I'm going to square root both sides. Square root both sides. So our height is actually, yes, Asbonge, I have had many a teacher mark your answer wrong if you don't mark Pythag, if you don't do this. They take a mark away from that. In fact, I've yet to see a teacher's paper that doesn't award a mark for writing Pythag. Okay, so it's very important that we write that Pythag there. Okay, so our perpendicular height is actually equal to 12 centimeters. Now I can calculate for the area of my, I can calculate for the area of my triangle. Area is equal to half of the base. Remember, my base is not 5 centimeters. My base is 10. I just split it in two so that I can calculate for the perpendicular height. Half of the base, which is 10 centimeters, so half of 10 multiplied by the perpendicular height, which is 12. And if I punch that into a calculator, I'm going to get 5 times 12, which is 60. 60 centimeters squared. All right, give me a thumbs up if what I've just explained makes sense. Not necessary, Lucanio. I don't think it is. Okay, it's perfectly fine if we don't do it, Lucaniso. It's fine. Okay, as long as you're using it appropriately in the question. Okay, now, this is how we have to do this. Every time we're calculating for the area of a triangle, we need the perpendicular height. Now, what happens if I give you a triangle that looks like this? What happens when I give you an obtuse triangle? Now, if I give you an obtuse triangle, we're going to face a problem, right? In that, in this particular question, I could go from the apex of my circle, of my triangle, and draw a straight line down there that's going to give us a perpendicular height, right? Now, if I try to do this on this circle, if I go from my apex over there and I do that, are we winning? Are we winning? Is that a perpendicular line? No, that's not a perpendicular line. We can't use that, right? So we're going to create a perpendicular line. I'm going to tell you guys that my base over here is 6 centimeters. And I'm going to tell you that the length from here to there is 5 centimeters, right? Now, what I'm going to do with this is I'm going to go still from my apex like that. Instead, what I'm going to do is I'm going to draw my perpendicular line that way. I'm going to draw it in that direction. And then I'm going to tell you guys that the distance from here to there is 3 centimeters. Now, all I'm going to do here is I'm going to extend this line in this direction. What's going to go in that corner over there? What's going to go in that corner over there? "90 degrees, that's it, Kellen. Good. Yes, a 90-degree angle. I'm going to have a perpendicular line. What can I use then to calculate for my perpendicular height? I mean, not rocket science at this point. We already know. How are we going to calculate for the perpendicular height? Pythag, 100%. I'd like you guys to do that for me, and then we're going to have our perpendicular height there. Right, we know 8 squared is going to equal to 5 squared minus 3 squared. Do not forget your reason, Pythag. All right, then we're going to go 8 squared is equal to 25 minus 9. 8 squared is therefore 16. Square root both sides. Therefore, h is equal to 4 centimeters. So our height is 4 centimeters. All right. Pascal. No, my guy, don't even lie. No, my drawing is so much better. My drawing has improved. Don't lie. H is equal to 4 centimeters. You guys are so judgmental, guys. I'm a maths teacher, not an artist. Okay, so from this point on, our base is 6 centimeters and our height is 4 centimeters. Can we calculate for the area of our triangle from here? Are we all okay with how to calculate for the area of this part? I know, guys. I'm just being judged, hey? The judgment is real. Okay. All right, then we can calculate for the area of this shape. It's not even that deep. A is equal to half of my base, which is 6, multiplied by the height, which is 4. And we're going to get that our area is then equal to 12 centimeters squared. Right. Give me a thumbs up in the chat, everybody, if you are 100% with the different types of triangles and how we're going to calculate for the area here. You guys with me? Beautiful. Excellent. All right, we're going to move. We're going to move, guys. We're not going to, okay, I see somebody still writing. I'm going to give you guys like 5 more seconds and then we'll continue. Okay. Ah, guys, and I can already see Offense is about to say it's giving Zimbabwe, and I'm watching you, Offense. I got my eye on you, and it's giving what? It's giving what? You see, you're starting. Okay, all right. Here's our next challenge. All right. Here's our next challenge. It says here, the diagram shows a wooden block that has a hole drilled into it. There's a hole drilled in our block. The diameter of the hole is 2 centimeters. Calculate the volume of the solid, giving your answer correct to 2 decimal places. Now, we're definitely going to need a strategy here, guys. Go, I'm watching you. Okay, so who has any idea? Like, how can we conceptualize what's happening here? What do we do? You know, correct, Pascal, 100%. Good, Amber, yes. I love it. Okay, cool. So we're going to have to identify the shapes that we're going to use here first. Correct. So we know that our thing is made up of 2 different shapes, right? The first shape is the rectangular prism. The rectangular prism. And the hole that's been drilled in here is the what? What kind of shape do we have that's drilled out of this? Correct, Pascal. It's a cylinder. Excellent. It's a cylinder. Now, we know that the cylinder part has been taken out. It's been taken out. So what are we going to do? Once we found the volume of this cylinder, what are we going to do? Yes, Pascal, beautiful. We are going to minus. Well done, Randile and Cassidy. Yes, we're going to minus. So what we're going to do is we're going to find the volume of the rectangular prism, and we're going to minus the volume of the cylinder. Okay. All right. I want to give you guys a few minutes to work this out. Once you are done working it out, please give me your favorite emoji again. Pick your own emoji, pop your answer in the chat. I want to remind you one more time that they say that the diameter of the hole is 2 centimeters. When we calculate for the volume or even the area of our cylinder or our base of our cylinder, do we need the diameter? Is that what we need? We don't need the diameter. We need the what? Correct, Jenna. Good. We need the radius. So the fact that they've given us the diameter leads us to the thing that we actually want, which is the radius. Okay, we want the radius. So remember that, guys. When you are done, I'm going to give you guys a few minutes. When you're done, pop your answers in the chat. I'm just going to grab my charger for the 100th time. I might need to get a new computer. Samuel, favorite emoji, please. Thank you. Oh, sorry, Akwando. Okay, I'm getting quite a few emojis in the chat. I've only got about 5, so I'm going to give you guys a little bit more time. Okay. Yo, Moeketsi, that's such a scary looking emoji. Kinda, just like one eye. I see. I'm gonna have to get used to it, Moeketsi. It's fine. You use whatever emoji you feel like. It's all cool. All right, I think that's enough. That's enough emojis. I think many of us might be already done with the question. All right, let's look at this. We know that the volume of the rectangular prism is going to be length times breadth times height. So we're going to get 4 times 6 times 6. So the volume over here is going to be 4 times 6 times 6. And we're going to minus that from the volume of the cylinder. Now, I know that the volume of my cylinder is the area of the base multiplied by the perpendicular height. So I know that the area of my base is going to be pi times my radius, which is 1, all squared, multiplied by the perpendicular height, which is 6. All right. Pop your answers in the chat, guys. What is the answer that we got for this over here? What did we get as an answer? Correct. Good. We get 125.15 centimeters cubed, which is lovely. All right. I feel like a little bit, I feel like I made this lesson too easy. I made this lesson way too easy. Teacher Nelly, what do you think? I feel like I made this lesson too easy. Because you guys are just doing the things here. And me, no, yeah. This lesson, it's too easy. So let's step it up a notch. Okay. Jenna's like, I'm not complaining. It was a walk in the park. So we're not going to help each other out in this next one. You guys, go for it. There's your next challenge. All right. Nobody help anybody, nobody in the chat. Only when you are done, you can pop your emoji in the chat. But we are not helping each other, né? We want to see where everybody's at. Do what you got to do, peeps. No, Pascal, don't run away from a challenge. Come on, we got this. We got this. Break it down into its shapes. Think about the shapes that you've got. sorry, Mweketsi. Sorry. Yes, Lwandile. Lwandile is onto something. Lwandile is giving me all the answers there in the DMs. I see you. You've got the absolute correct idea. Keep going. You got this. Nice, Pascal. No H this one. You got this. Like teacher does the dramatics. Kirle dramatic. Apiwe a dramatic. Dramatic. How, Akwando, it's not even that much thinking. You just called it a walk in the park, my guy. Okay, one more minute, guys. I thought I just had to do it. Okay. All right, peeps, that's time. Okay, let's have a look at this question very quickly. Okay, so it says here, a concrete beam is to rest on two concrete pillars. The beam is a cuboid with slides of length 0.5 meters, 3 meters, and 0.4 meters. The pillars have diameter, again, they give us the diameter of 0.4 meters and a height of 2 meters. Calculate the total volume of concrete needed to make the beam and the pillars. Round your answer to a sensible level of accuracy. Okay, I like the fact that they're saying this, a sensible level of accuracy, and we're going to speak about what that actually means in just a bit. Okay, so we know that we've got the volume of the rectangular prism, right? Rectangular prism, and then we're going to get the volume of the cylinders, but we're going to find the volume of the cylinders times 2, because there are 2 cylinders. Right, times 2, correct, Pascal. Good, so we can find the volume of the, of our cylinder, not our cylinder, our prism. That's easy enough. We're just going to take 3 times 0.5 times 0.4, and we're going to get that answer, plus the volume of the cylinders. We know that the diameter is 0.4, which means our radius is actually 0.2. So because our base is a circle, we're going to have pi times 0.2 all squared multiplied by the height, which is 2, multiplied by 2, because there are 2 pillars. Okay, multiplied by 2. And if we punch this into a calculator, give me an answer, peeps. What did we get? How much did we get? We're getting 1.10 meters cubed. Let me just double check to see that your mathematics is on point. Plus pi times 0.2 squared times 2 times 2. 2 again. Let's see. Correct. I also get that. I also get 1.1 meters cubed. Okay. Right. Okay. Let me ask this question because we're basically done here. Right. If I asked you guys to round this this number off, what would you round that measurement to? What would we round it to? If we had to round it, what would we round it to? Okay, I figured somebody would say 1 meter. Jenna would say 1 meter. Now, why do I say, I want to see if anybody can figure out why I'm saying we cannot round this thing down to 1 meter. Who has figured it out? Why? Why can we say that? Why can we not say 1 meter? What's the problem? Let's read the question one more time. Why can we not say, yes, Lwandile, 100%. We have to round up. So why can we not round down? Who can tell me this? No, not because of cubed. Yes, it has something to do with sensible. You're right, Amber. Okay, but what exactly are they doing? What are they doing in this particular question? What is happening in this particular question? What do they want to find out? Jenna, correct. Okay, I want everybody to look at Jenna's comment. Right. Jenna says, if we round down, we won't have enough what? We won't have enough concrete. Because we are looking at the amount of concrete that we need in order to make this. If we round down, we are going to run out of concrete. Okay, so we cannot possibly round this number down. And that's what they mean when they say to a sensible level of accuracy. They're also talking about the decimals, yes, but because we want to know how much cement we need to buy, we cannot round down. We must round up. Okay, okay. All right. Okay, that's the rest. That's it for today's lesson.